This is 30th of January 2025 and we're going to continue our work on the organic chemistry topic on alkenes. We just did a starter where we practiced drawing alkanes and alkenes up to 4 carbons, and we remembered that alkenes have got a double bond, alkanes don't. We remembered the general formula of alkanes and alkenes. I'm not going to do that again now. But we need to be able to know the reactions of alkenes. And it all comes from the fact that alkenes are unsaturated, which we mentioned yesterday, which means they have a double bond. And at GCSE, it's only ever one double bond. I've never seen a GCSE question with more than one double bond. Doesn't mean they can't exist with lots of double bonds. That doesn't. Lots of molecules have got lots of double bonds. But at GCSE, you're only going to get asked questions about one double bond.
Does a triple bond exist?
Yeah, triple bond does exist. It's not covered in the course though. Yeah, so they're called alkynes, but we don't cover them. So they have a double bond, and they're quite reactive because of that double bond, or more reactive than alkenes.
Than alkanes, so
They're more reactive. They're more reactive than alkanes.
you said more reactive than alkenes.
Thank you. So more reactive than alkanes because of the double bond. And you know, and I think when we stop doing writing, I think I've shown you before, but I've asked to have the stuff to demonstrate again the test for alkenes, which I'm going to remind you again now. And when you're writing chemical tests, remember that you state what the test is and what the outcome of the test is. So the test for alkenes is you add, or shake with is even better, shake with bromine water, and then the result is the bromine water goes from orange to colourless. And I'll show you what's going on in that reaction as I start to talk you through the reactions they can undergo. A kind of fairly general point though about alkenes is they tend to burn with a smoky flame. They tend to burn with a smoky flame, and that's because of incomplete combustion taking place. And so you're getting kind of certain unburnt hydrocarbons given off. Okay. Right. So what we're going to do now is go through a whole load of reactions that alkenes can undergo, and this is quite a lot to learn here, and we're going to need to learn and practice and learn. And it will work in class, but it will work so much better if you can find a bit of time to try to commit these to memory yourself. And the reason I'm referring to the textbook here is I just want to make sure I get all of them as I'm going along. I don't want to miss anything, so I've got this to hand to make sure I don't have any. I'll remind you before I start that we get alkenes, as we said yesterday. We get them from cracking of long chain alkanes. From cracking of long chain alkanes. Sort of like yesterday. It's a bit of recapping there. Okay, just remind you of that. So the reactions that alkenes undergo are, apart from combustion, which is simply burning it with oxygen, the reactions of alkenes are all essentially the same, but there's quite a few of them. But as I say, they're all basically the same, and they're all what we call addition reactions. All addition reactions. And essentially, that means that 2 becomes 1. Okay, so two reactants become one product. So 2 reactants, 1 product. So do you remember the old Christmas number 1? 2 becomes 1. I think the Spice Girls. All a bit too young for that. 1 or 2 people nodding. Remember that? You remember that, don't you? 2 become when 2 become 1. You remember that song?
They played Spice Girls on my nan's funeral.
Lovely. Thanks for that. That's a good story. All right. So anyway, so 2 becomes 1. And that means that all of these reactions I'm going to talk about, including the last one I'll get to, which is polymerization, they're all what we call 100% atom economy. I'll remind you now that atom economy is one of those quantitative chemistry skills that lots of people forget. I don't want to teach you atom economy again now, but you should be able to work out atom economy from a balanced equation. So very briefly, the mass, the formula mass of the desired product divided by the formula mass of all of the products times by 100 is atom economy. If you've only got 1 product, by definition, you're going to get 100% atom economy as no byproducts. So I'm going to go through a series of these now, and then I'm going to help you by creating a revision sheet at the end of it. So the alkene I'm going to use every time is ethene, but you could use any alkene. You could use propene or butene. It would do exactly the same thing. So the first one we're going to look at is adding hydrogen to alkenes. Okay, and you need to know for this that I was just checking that to see whether you need to know which catalyst it is. But all you need to know is that you need a catalyst. The catalyst, by the way, for those who are interested, is nickel. And you end up getting 2 hydrogens added across that double bond. So one of the hydrogens adds to one carbon, and the other hydrogen of the H2 adds to the other carbon, and we end up getting ethene like that. I'll take a question if you've got one. Yeah.
Will the alkene be in liquid form?
In this particular case, no. This stuff is a gas, but it could be. So the alkene that I'm going to show you when we do the demo will be a liquid. This particular one happens to be a gas. It makes no difference to this reaction. Okay. There are lots of catalysts you can use, but the standard one to learn is nickel. But you only need to know that it's a catalyst. But can you see 2 hydrogens? One adds to one carbon, one adds to the other. So now we've got 3 hydrogens on each carbon. Okay. The next, you need to know that you heat it. Let's just say, little detail here from the textbook, 60 degrees C. If you can learn that you heat it a bit, that'd be nice. But that reaction can be quite rapid at room temperature even, depending on the particular alkene you've got. Right, so another example of a reaction. This is less obvious, I think, to see, but I'll show you it, then you can copy. So I'd quite like you to look this way and see what I'm doing, and then you can copy it up. So there's ethene. If you react water to it, but it has to be in the form of steam, and you're expected to know that, and you do that in the presence of again a catalyst, and that catalyst, by the way, well, it doesn't say you need to know it, but I'm going to tell you anyway. Phosphoric acid is a good one. Also works with sulfuric acid, but phosphoric acid is often used here. So steam with the alkene, and that will give you this, and I'll walk you through how this forms in a second, or very briefly at least. So you get that stuff formed, and that's an alcohol, that's ethanol. That's the stuff you find in vodka, for example.
Yum.
Okay, right, so what's going on there is if I draw the water underneath the alkene, hopefully you can see it like this. There's the water drawn in a slightly weird way, but this hydrogen ends up on that carbon, and this OH ends up on that carbon. That's what's going on there. How the reaction occurs and the process by which it takes place is well beyond the scope of GCSE. You just need to understand that the hydrogen from water, or one of the hydrogens from water, goes on one carbon, and the OH from the water ends up on the other carbon. You end up with this thing here. This is ethanol. And this is an example of an alcohol. There are lots of alcohols: methanol, propanol, butanol, and we'll learn about alcohols next lesson. Okay, it's not as exciting as you think. I think. It's worth knowing that this is an important process, although we'll come back to this a bit more when we do alcohols. So this is an important industrial method for making ethanol, and we'll come back to that when we do alcohols in a bit more detail. We need to know that alcohol is used for lots of things, including as a fuel now. So, so ethanol, you need to know some of the ways that it's made. Do you remember during the pandemic we were all washing our hands or rinsing our hands with like hand sanitizer? Those hand sanitizers have this chemical. This is what was doing the disinfecting. Yeah.
What's the name of the catalyst?
So it's H3PO4 and it's phosphoric acid. I should put that in brackets really, because it's not clear that you need to know that. Okay. In fact, you don't need to know that. Right. Just so I know that you're with me, I want you to put your pens down when you've done that. I'm going to pause the video for a sec. We'll do some mini whiteboard stuff, and we'll come back to some more in a sec. So what we just did is we practiced drawing some alkenes and whatnot, and the hydrogenation of alkenes was fine. But let's have a look at what happens, because quite a few people got this wrong, when we add steam to a different alkene. So we add water, steam, we add phosphoric acid catalyst, exactly the same as before. The OH adds to one hydrogen, and the hydrogen adds to another hydrogen across that double bond. It's that double bond that's reactive, it's the double bond that does the work. And there are two possible products, both of which I said I'd accept. Most of you drew this one. But look, some of you drew the OH the wrong way round. Oxygen makes two bonds, and so it must be in between the carbon and the hydrogen. So I added the hydrogen to this carbon, and I added the OH to the other carbon, and the double bond has now disappeared. Okay, so that's 100% atom economy as well. Okay, so that's the reaction of propene plus steam. You could do it with butene, you could do it with any alkene. Some of you wrote the alternative product, which I'll just show you here, and both are possible. But that's, in reality, this one's more likely, but anyway, you don't need to know that. So there we go, that's what goes on there. So you've got propene plus steam, but there's some other reactions of alkenes we need to know as well. So the reaction with halogens, and halogens, by halogen, I think the word halogen confuses people. I think you know halogens are group 7, but what I mean by halogen is the diatomic elements. Diatomic meaning two atoms. So diatomic, so what I mean by that is chlorine or bromine or iodine. They'll all do the same thing.
Not chlorine.
Chlorine, bromine, iodine, Cl2, Br2 or I2. F2 we don't tend to use particularly because it's so reactive, it's quite dangerous to work with. It probably would do exactly the same thing, but making it, actually using it is pretty tricky. So reactions with halogens. Now hopefully you're starting to get the picture that alkenes react always in exactly the same way. And it's addition, and I'm going to use Br2 as my example here. You don't need any special conditions for this. You just give it a little shake. This is bromine water, it could be, couldn't it? So a little shaky, and you end up with one of the bromines adding to one of the carbons and the other bromine adding to the other carbon. So you end up with this. And by the way, as long as the one bromine is attached to each carbon, it doesn't matter which position it's in on that carbon. So something like that. This stuff you're expected to know. This is 1,2 dibromoethane. Expected to know by me at least, or you don't even need the 1,2, but dibromoethane. Di because there's two of them, bromo because we're referring to the bromine, ethane because it's a alkane now with two carbons. Dibromoethane. This is ethene, and this is dibromoethane. Why has the name changed from ene to ane, would you say, Sky? Because it's saturated. Yeah, exactly. There's no double bond there. Good. Well done. All right. You could do that with Cl2 or I2 as well. But remember that this stuff, bromine in water, is orange, and this substance here, the bromine is gone. This stuff is colourless. This is the bromine water test, isn't it? You add bromine to an alkene, it will go from orange to colourless. And it's worth saying at this point that the bromine water test gives no reaction with alkanes, so the bromine stays orange. I don't think you need to know any other reactions, but I usually teach one more, and I'm going to, just in case, you never know, this comes up. In fact, two more things. One is sometimes the GCSEs, in fact a lot of the time the GCSE papers ask you things that you might be able to work out based on what you already know. So I'm going to pause the video. On your mini whiteboards, can you draw what you think the product of this might be, please? And have a go at naming it if you're feeling clever. I'll pause it and show you in a second. I'll draw that now. Most of you got that right, or got close to getting it right. The hydrogen adds to one of the carbons, and the bromine adds to the other one, and that stuff would just be called bromoethane, not dibromoethane because it's just one, just simply bromoethane. That's it, that's all you've got to be able to do. There's one more reaction that I'm going to spend time on in a future lesson. I'm not going to do it as part of this lesson, which is alkenes undergo addition polymerization. That's a really important process, but I'm going to spend a whole chunk of time on that. I don't want to do that now, so I feel like it's the right time to do it. Okay, addition polymerization. So alkenes, when you think alkenes, think addition. What we're going to do then is just do a little summary sheet, which will help you with revision. It's the kind of thing you do for revision, and then reproduce this as part of your revision work. Okay, and then I'll show you the bromine water test again, and then we'll move on to something else. Okay, all right. Yeah.
What are each of the reactions called?
Sorry, what are the?
What are the separate reactions called?
So they're all addition reactions. So what I've called them here, so the reaction with halogens, the reaction with halogen halide, they're all addition, but they all come under the class of addition reactions. That's really what alkenes do. Okay. You could call them bromination or monomer, but yeah, I think we'll just keep to what you need to know for the course, which is like the fact they're addition reactions. So a nice way of summarising this is with a little sort of mind map. So let's work on one of those together. What we'll have is ethene there, which we have coming from a long chain alkane via the process of cracking, which requires, remember, a high temperature and either a catalyst or steam. Okay, we end up with an alkene. I've just drawn ethene as my example alkene product, and then I'm just going to circle around it all the things you can do with alkenes. So one of the things you can do is add H2 with a catalyst. You see that up there? To give, this is already, it's the same as what we've already written, it's just summarising it, and this is the kind of thing, one of the ways you can practice. Stay with me please, keep doing what I'm asking you to do. I'm going to use a different halogen this time, just to make the point that it can be any halogen will do exactly the same thing. Notice that in each case, the double bond has gone. Double bond is now saturated, or the molecule is now saturated, there's no double bond in there. So that's a dichloroethane now. Again, it's addition. The one that you probably hardest to learn is steam, isn't it? In the presence of an acid catalyst, which is phosphoric. And you get the alcohol. Please make sure that when you draw the alcohol, the O is always touching the oxygen. The oxygen is always touching the carbon, and the oxygen is always touching the hydrogen. But hydrogen only makes one bond, so it has to be that way around. Oxygen makes two bonds, so it has to be that way around. We also learn, although I don't think it's required, that we could add any halogen halide to an alkene. Did I say halogen? I mean hydrogen halide to an alkene. Let's give you that. And we'll come to, in time, just copy this for now, as best you can. We may have looked at this last year a little bit. An addition polymer. So just do your best to copy that for now and practice that together. And then always worth remembering as well that we can burn these in combustion with oxygen. Will give you CO2 and H2O, and it's often the water that's forgotten. You fully oxidize hydrogen, you get water like any other hydrocarbon, but you could also get, and likely to get, carbon soot particulates and carbon monoxide, which is toxic as well. All right.
So, do you not get complete combustion with an alkene?
You can get complete combustion if there's sufficient oxygen. You're more likely to get incomplete combustion, which is why I put it in brackets, that you get complete combustion and you can get incomplete combustion as well. You can definitely force it to go if you mix it well with oxygen first. You're good. It's about getting those ratios right. Something I probably should have mentioned at the start, but do you still need that up? Is that alright? Who still needs that up? Yeah, keep going then. I think it's probably worth defining the term homologous series to you, because that came up in the questions yesterday, didn't it? And I haven't shown you what that meant, so I'll just write that underneath as well. Homologous series. So this is what we call a family of a family of organic molecules with the same functional group, e.g. double bond. Yeah, some people still put in the picture, that's fine. So homologous series is a family of organic molecules with the same functional group, like a double bond. They all have similar properties, or I should say similar physical properties. Although the longer they get, they increase in boiling point because the intermolecular forces get stronger, as we've covered lots of times. And they have very similar reactivity to each other. They have the same general formula, but they differ by CH2 each time. So as you go through the homologous series, you increase CH2 each time. So you go from ethene to propene, you add CH2. From propene to butene, you add CH2, and so on. Okay. So you need to know the definition of homologous series. So that's the kind of thing you'd be writing on flashcards and committing to memory. Okay. I think that's a good place to stop, actually. So rather than teach something new, what we'll do, what we'll do is we'll do some practice between now and the end of the lesson. We'll try and commit some of this stuff to memory. So if you're one of the people not here and watching the video, please practice this because it will help.